Soap. I make and I sell soap.
Inspired by one of my favorite novels, Chuck Palahniuk's Fight Club, I decided to do my project on the subject of soap making. Soap making is an ancient practice, dating back to Babylon in 2800 BC. For a point of reference, this means that the first recorded recipe for soap predates the domestication of the horse by nearly 1,000 years. What's even more shocking, however, is that the basic recipe of soap hasn't changed at all since its inception. Soap is still today made out of the three same ingredients: lye, animal fats, and oils. I began my research on the recipe for soap and the science behind it before attempting to make it in the lab myself. What follows is my own experience making soap and my filmed process of creating it. I soon learned that lye, better known as Drano as its commercial product name, is one of the main ingredients for soap. Lye is actually just sodium hydroxide. Sodium hydroxide itself is a very basic substance that can corrode not only through flesh and skin, but also metals and certain plastics. It's also worth stating that I use the lye crystals, or the sodium hydroxide crystals, and I mix them with H2O, or water, to create a lye solution. This is because the lye solution is aqueous, and although the H2O plays no role in the chemical reactions of soap making, it's much more ideal to facilitate the reactions that create the soap. The oils and fat used for soap are actually just acidic triglycerides made up of fatty acids attached to a central glycerol molecule. These fatty acids are also known as esters, which means they are of a carboxyl nature. After measuring out the various substances according to my recipe, I began to pour the lye solution onto the fats and oil, and then stir all the substances over a heated hot plate. This is when the real reaction happens. The base and the acid react with each other because of the heat being applied in the stirring. This process is called saponification. The ester bonds with the long fatty carboxylic acids of the triglycerides begin to break off from the central glycerol molecule. This is because the sodium hydroxide accelerates the breakdown of the ester bonds, which can then be easily broken by heat and movement. The series of chemical reactions is formally known as saponification. After saponification has occurred, only two products remain: soap and glycerol. Glycerol is a skin-nourishing substance that most soap manufacturers skim off the finished product of soap and sell as a separate skincare product for an added premium. Now, still corrosive soap must now be left alone for 24 to 36 hours in an insulated environment before it can even be touched or used. So, after waiting for 24 to 36 hours and leaving it in an insulated environment, this is what my soap product looks like. Now, I think you can pretty clearly identify that it's solid soap, and if you look closely, you can actually see the glycerol trapped underneath or above the solidified soap. Now, it certainly doesn't smell like any kind of commercial soap you would buy, but this is because it didn't use any kind of scenting oil or anything other than the core ingredients of lye, oils, and animal fat. So it just smells like animal fat. All the same, it is soap. You could use it to clean things. Thank you for your time. I hope you enjoyed learning about soap and saponification.